Hi guys, I trust that you're feeling well and awesome. Welcome to this video on grade 10 mathematics, and in this video we'll be having a look at analytical geometry, particularly with the distance formula. So we'll have a look at an introduction to analytical geometry, how it differs from Euclidean geometry, and also we then look at the content of today's video, which is actually the distance formula. So without any further ado, let's get straight into it. So, analytical geometry, which is also known as coordinate geometry, this is the study of geometry using coordinates. So, when we're talking about geometry, we're basically talking about lines and shapes. We're basically seeing how we can incorporate the concept of lines and shapes into the coordinate system, into a Cartesian plane. So, the following subtopics are what we need to know in grade 10. The distance formula, the midpoint, gradient of a straight line, parallel and perpendicular lines, if you can remember that from Euclidean geometry, as well as the equation of a straight line. So let's get straight into the distance formula. If we are given 2 points with the coordinates x1, y1 and x2, y2, so let's say for instance we've got point A here with the coordinates x1 and y1. Then we've got point B somewhere here with the coordinates of x2 and y2. Now let's say we've got these 2 points here. We can have a straight line joining the 2 points. That line is not very straight, but let's pretend it's a straight line. And for us to calculate the length or the distance between A and B, the distance of the line segment joining A and B, we could use the equation that is highlighted up here, also known as the distance formula. Now notice that it's not compulsory for you to start with x2 and y2. You could rewrite the distance formula in the second approach where you start with x1 and y1. The only rule, however, is if you start with x1, then you must start with y1. If you start with x2, you must start with y2. A scenario like this does not make sense, where you've got x1 minus x2 squared plus y2 minus y1 squared. This is absolutely wrong and should be avoided at all costs. So, once again, we use the distance formula to find the length of a line joining 2 points. So one way that you will see that you need to use the distance formula is that the question will say to you determine the length of some line, as we would see in the next few examples. So let's get into some examples. We are supposed to find the length of the line segment joining the points -3 and 2 and 4 and -3. So let's go to the writing pad and let's write this out. So we've got the coordinates -3 and 2, and then we've got 4, and let me just confirm here. Whoops, this is -4 and -3. So the first thing we need to do is to label our points. I'm going to call this x1, I'm going to call this y1. This is going to be x2, this is going to be y2. It does not matter which one you refer to as x1 or x2, as long as you make sure that x1 goes with y1 and x2 pairs with y2. So to calculate the distance, we could use the equation that we've learned just now. So x2 minus x1 all squared plus y2 minus y1 all squared. Let's see what this is going to give us. So this is the square root of, for x2, we've got -4, minus x1, which is -3. It is important for you to put this in brackets because the negative and the negative will multiply out to give you a positive. Then we add this. y2 is -3, minus y1, which is 2 squared. And so this is going to give me the square root of, so we've got here -4 plus 3 all squared plus, this is going to be -3 minus 2, which is -5 squared. Now, if we simplify this, we are going to get -4 plus 3 is -1 squared plus, this is -5 squared. Now this is going to give you the square root of 1 plus 25, which will just give you the square root of 26. Depending on whether the question wants you to leave your answers in decimal form or surd form, if it's surd form, we are done here. If it's decimal form, you will type the square root of 26 on your calculator, get the answer into decimal form, then you write it out as your final answer. Awesome. I hope that this makes sense. So let's look at the next question. It says we need to find the length of AB if A is negative 6 and 7 and B is 0 and 2. So, once again, we need to use the distance formula for this. Let's first start by copying over our coordinates. So, we've got the coordinates of A, which are negative 6 and 7. Then we've got the coordinates of B, which are 0 and 2. Once again, I'm going to name this x1, I'm going to name this y1. I'm going to name this x2, I'm going to name this y2. So, the distance of AB is going to be equals to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. In some textbooks, what you will see that they will do is they would say, for example, x of b minus x of a all squared plus y of b minus y of a all squared. You could also use it like this to avoid the confusion between what's y1, what's y2, and the likes. You just know that you substitute the correct coordinates. So, x2, this is 0, minus x1, which is minus 6, all squared. Don't forget the closing bracket, plus. Then for y2, this is 2 minus y1, which is 7, all squared. This is going to give us the square root of 0 plus 6 all squared plus 2 minus 7, that's negative 5 all squared. Now, this is going to give us the square root of 6 squared plus negative 5 squared, which is the square root of 36 plus 25. Now, once again, if you add if you add 36 plus 25, that is going to give you, let's see, this is going to be the square root of 61. Once again, if you have a calculator, you can type this in your calculator, get the answer in decimal form. But if the question asks you to write your answers in surd form, then you are done. Perfect. Life is great. I hope that you guys are enjoying the content. I hope that you're finding it productive, that you're learning something. If you are, please don't forget to subscribe. Please don't forget to hit the like button and share this video with other people as well. Right, here's an interesting question. We're supposed to determine y if PQ is 13, P is 8 and y, Q is 3 and 9. Now notice in this case we are given the length or the distance. Ours is to find the value of y. So let's go to our writing pad and let's see how we would do such. So the first thing I would do is probably take out a new sheet of paper and let's write down what we know. So we know the length of PQ is 13. Then the coordinates of P are 8 and y. Then the coordinates of Q would be 3 and 9. Right. Now let's start off by writing our formula. PQ, I'm supposed to call this x1 and y1. It's always important to label your coordinates first before you attempt to answer the question. This is the square root of x2 minus x1 all squared plus y2 minus y1 all squared. And this is going to give you the square root of, for x2, we've got 3 minus x1, which is 8 squared, plus y2 is 9, minus y1 is just y squared. By the way, this is 13, so let's continue. 13 will be equals to the square root of 3 minus 8, that will be negative 5 squared plus. Now notice that we've got a bracket squared. If you can remember on products, we are supposed to multiply out the bracket. So 9 minus y, 9 minus y. Right, if you can remember from products, 13 will be equals to the root of, we've got a product here, so we need to multiply out the bracket. So negative 5 squared will give us positive 25 plus. Then 9 times 9, that's 81. 9 times negative y, that's negative 9y. Negative y times 9, that's negative 9y again. Then negative times negative, that's going to give us positive y squared. Now we simplify. 13 is equals to the square root of 25 plus 81. That's going to give us 106. Then we've got like terms. Minus 9y, that's going to be minus 18y. y plus y squared. Now, I have a little bit of a problem with this square root. So to get rid of the square root, I'm going to square both sides. Now, 13 squared, that's going to give us 169. This is equals to, square root disappears, 106 minus 18y plus y squared. Now I'm solving for y. This is a quadratic equation. First, I need to take the 169 over to the other side. So 0 is equals to, let's write the equation in standard form. Y squared minus 18y plus 106 minus 169. Now, the reason why we had to take over the 169 is for us to have, once again, as I've mentioned, a quadratic equation where we will be able to solve for y. So 0 will be equals to, this is y squared minus 18y, then 106 minus 169, this is going to give us negative 63. When you get to this point, you know that you need to factorize this. So we can have our factors there. This is y, this is y. This is, whoops, that is not squared. Our last term is negative, so this should be positive and this should be negative. And now we need to find factors of negative 63. Factors of negative 63, we've got 1 and negative 63. Then next, what we need to do is we need to check 2 does not go into negative 63. So let's try 3. 3 does go in. 3 actually goes 21 times. So we've got 3 and negative 21. Actually, I'm going to stop right here, because if I say 3 plus negative 21, this gives me negative 18, which is the coefficient of the middle term. So let me put in positive 3 and let me put in minus 21. When you get to this point, you take each bracket and you equate it to 0. We take the 3 over, we get y is equals to negative 3. We take minus 21 over, we get y is equals to 21. Perfect. There we are. Life is great. Let's look at the next question. Once again, in the next question, we're given the length of xy as 5. And the question says to us, we need to find the value of x. If the coordinate of capital X is 6 and minus 2, y would be x and 2. So let's go back to our writing pattern. Let's have a look at this again. So the first thing we are told is that xy is equals to 5. We are given the coordinates of x, which are 6 and minus 2. We are given the coordinates of y, which are x and 2. Let me start by labeling. This is x1, this is y1. This is x2, this is y2. Now, xy is equals to the square root of, this is going to be x2 minus x1 all squared, plus y2 minus y1 all squared. This is going to give us 5 is equals to the square root of x2, that is x, minus x1, that is 6 all squared, plus y2 is 2 minus y1, that's minus 2 all squared. 5 is equals to the square root of, we've got a bracket which is squared, so x minus 6 into x minus 6, plus this is going to give us 2, and then negative times negative is positive 2 all squared. 5 is equals to the square root of x times x is x squared. X times minus 6 is minus 6x. Minus 6 times x is minus 6x. Minus 6 times minus 6 is positive 36. Then plus, this is 4 squared. So 5 is equals to the square root of x squared. We've got like terms, minus 6x minus 6x, that's minus 12x, plus 36. Then 4 squared, that will give us 16. So 5 is equals to the square root of x squared minus 12x, we've got like terms, 36 plus 16, that's going to give us positive 52. Once again, let's get rid of the square root sign. To get rid of the square root sign, we need to square both sides. So 25 will be equals to x squared minus 12x plus 52. Now, this is a quadratic equation we need to take over the 25. So 0 is equals to x squared minus 12x plus 52 minus 25. Now we just need to go ahead and work out what is 52 minus 25, and then we go ahead and solve for x. So this is x squared minus 12x, 52 minus 25, that's going to give us positive 27. Once again, we need to factorize this. So I'm going to have 0 is equals to 2 set of brackets. There's x here, there's x here. My last term is positive, meaning that the signs in the bracket should be the same. Which sign am I taking? The sign of the middle term. So this is negative and this is negative. Factors of 27. We've got 1 and 27. We've got 3 and 9. We've got negative 3, negative 9. We've got negative 1 and negative 27. When we get to this point, we need to add our factors. So 1 plus 27 is 28. 3 plus 9, that's 12. Negative 3 plus negative 9, that's negative 12. Negative 1 plus negative 27 is negative 28. Negative 3 and negative 9, when we add them, we get negative 12. So these are the factors that I'm taking. Negative 3, negative 9. Then I need to take each bracket and equate it to 0. I take the minus 3 over, I get x is equals to 3. I take the 9 over, I get x is equals to 9. Perfect. Life is great. Once again, if you guys are enjoying the content, please give us a like, subscribe to the channel, share this video with other people, and should it happen that you have any questions, please leave them in the comment section. And let's look at the last question. So the last question says we need to find the length of JK. We're given the coordinates of J are P and Q. K is P plus 4 and Q minus 1. Let's get into this one. Notice that this time the length of JK is not given, but we're given the coordinates of J are P and Q. Then we're given that the coordinates of K are P plus 4 and Q minus 1. Now we need to use the distance formula. So first, this is x1, this is y1. This is x2, this is y2. So jk is equals to x2 minus x1 all squared plus y2 minus, whoops, not y squared, but y2 minus y1 all squared. This is going to give us, for x2, this is p plus 4, minus x1, which is p, all squared, plus, for y2, we've got q minus 1, minus y1, which is q, all squared. Now notice, in the first bracket, p and negative p cancel out, we just remain with 4 squared. In the second bracket, q and negative q cancel out, we just remain with minus 1 squared. This is going to give us 4 squared is 16, and then negative 1 squared is 1. This is going to give us jk. Whoops, I am committing a fatal mistake because I forgot the square root. Square root and square root there, square root there. So we're going to have jk is equals to the square root of 17. There we have it. Wonderful. Life is great. I hope that this video was informative. I hope that it was productive, and I hope you guys enjoyed what we were doing here. If you did, please give us a thumbs up. Please subscribe to the channel. Most importantly, please share the video with other people so that they can benefit from the same knowledge that you're learning from. Also, if you have any comments, any specific requests, or any questions, please leave them in the comment section and we'd be happy to get back to you. Until then, enjoy the rest of the week. Ciao.